I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now would you make welcome straight from Washington, D.C., the United States Army Corps Quartet.
Yeah.
Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the
Oh yeah! Come on, folks, let them know it.
America's finest, the United States Army Barbershop Quartet, performing at the Barbershop Quartet Convention in 2015. We thank these gentlemen for their service. We thank all of our servicemen around the world, where men and women around the world, wherever you might be, and our allied forces that help protect their own countries and help the United States protect the world. God bless you all. May you all return home safely after your tours of duty end. And thank you again for your service. Folks, we have a lot of things to talk about tonight. I want to apologize for no sound at the beginning. Again, the AI hit us. Doggone them. Anyway, we have sound here, I hope. Will somebody please give me a 5x5 before we continue? I hope we have sound now. Susan Stater says it gives me goosebumps every time she hears that music. I agree, it does me too. Richard Smith says there's a 2.9 and a 3.9 in Western Texas. Oh yes, there is. Everybody says sound is good. That's great. Thank you guys. I appreciate that. Folks, we have a great program for you. I want to tell you that Juanito from the Imperial Valley, Southern California, was the first to hit here to our program tonight. Thank you, Juanito. Thank you, everybody, for being here. We appreciate it. Folks, we're going to talk about volcanoes. We're going to talk about earthquakes tonight. A lot. Quite a bit we're going to talk about. I first want to talk about some earthquakes, okay? These were earthquakes that hit on Saturday, okay? Earthquakes that hit on Saturday. Look at all these 5.0 and larger earthquakes. Isn't that something? At 1:51 in the morning, a 7.1 in New Caledonia in the Southern Pacific. This is just west of the Loyalty Islands, where we had those 7.7s, which was an 8.0, and that 7.4, which was at least a 7.6. Yeah. Okay? That's what happened Thursday and Friday this past week. We got hit big time. Why? Because we had solar flares. We're going to talk about that in just a few minutes. And the earthquakes continue today. Look at all these earthquakes. New Caledonia, 151, a 7.1 Saturday morning. And it goes on and on and on. If I could show you all of the earthquakes that we had, it would be crazy. It's been insane. Literally insane. Look at this, guys. Okay, look at this. Let me enlarge this so you can really see it. Look at this. 2:57 Saturday morning. Actually Friday. This was Friday. New Caledonia, 7.7. 5.9, 5.7, 5.4, 5.1 in Tarapaca, Chile, northern Chile. And then the other earthquakes here in New Caledonia. Again, in the southern part of the Pacific Ocean. New Caledonia is a French island nation. Okay? Just like Puerto Rico and Guam is to us. It's a French island nation down there. And look over in Somalia. Okay? A 5.7 in Somalia. And it did damage. It did damage. Folks, there are a lot more earthquakes. There are a lot more earthquakes. It's incredible what we've seen. I find it to be crazy. Just extremely crazy. And then what happened on Sunday? Look at this. Okay? Look at Sundays. 5.0 in large earthquakes here. 5:23 a.m. on Sunday. A 5.8 in Tonga. I think that was really a 6.0. 5.2 Central Tonga again. Then the thing that really got things going yesterday, early yesterday afternoon, a 6.8, 7.0 magnitude earthquake on just off the southeastern tip of Africa, near Prince Edward Island in the South Atlantic. A 6.8, 7.0 earthquake. Now, I'm going to stop right there for just a minute. I want to make sure everybody realizes what's going on. We had 7.7s, which was an 8.0 over west of here in the South Pacific. Okay, the Loyalty Islands. Then we had the New Caledonia quakes as well. There were over 200 aftershocks from the Loyalty Islands. There were 50 aftershocks from the earthquakes that hit in New Caledonia. Then we had the very large earthquakes over in Tonga. Then this happens. There's interplate activity. The southern hemisphere is experiencing interplate activity. We had the South Pacific, right? Then we have activity in the Atlantic and the southwestern Indian Ocean. Okay? Huge activity. And it's not going to stop. As we saw that activity over off the southeastern part of Africa, that's going to go north. that activity is going to go north. Expect very large, very strong earthquakes to go up the east coast, east coast of Africa. Expect that. We've already seen very large activity in north central Chile. That activity is going to continue to move as well. The activity over in the South Pacific, the Loyalty Islands and New Caledonia, all that activity is also going to go east and west and north and south. I fully expect that New Zealand is going to get nailed this week. New Zealand, you need to be on watch for a very strong earthquake. I think New Zealand's going to get nailed. As well as Papua New Guinea, Indonesia, the Philippines, possibly Taiwan, then Japan, then over off the coast of Kamchatka Peninsula, and then we're going to see very strong earthquake activity in the Aleutian Islands and going over into Alaska. Count on it. That also is going to happen. Look at all these earthquakes here yesterday. 5.4 on the Antarctic Ridge over south of Australia. A large 5.4 on the Antarctic Ridge south of Australia. Over south of Japan, between Taiwan and Japan, we had a 5.5 earthquake hit there. Incredible. And the comment at the bottom, what a day. What a week. Okay? What a week, including everything that happened last week as well. What a week. And it's ongoing. I don't believe it's going to stop. I don't. Now going back to the Loyalty Islands. Okay? Remember what happened. Okay? Remember what happened. First, we have that 8.0 magnitude earthquake. 8.0 magnitude earthquake. Then we had the 7.4. Okay? The 7.4. This was the result of the 7.4. Look at all of these epicenters. All of these primary waves that go off the paper. Literally off the paper. Now, I'm going to count out with you the body waves from this earthquake, from the 7.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 body waves. Was this really a 7.4 magnitude earthquake? No. Not at all. This was at least a 7.6, and I'm going to even take it up to 7.8. Remember the 8.0 we had, that thing that they called a 7.8? 7.7, then a 7.8? It was an 8.0. Okay? It's incredible. It really is incredible. There's nothing like it. There's nothing like it. All of this power in the South Pacific, between the Loyalty Islands and New Caledonia. The power. That power of the first 8.0 in the Loyalty Islands, guys, it was equivalent to 9 A-booms. 9 booms. Starts with an A. Huge. Huge. Fortunately, there was not that much damage. It could have been far worse. It could have been very bad. It's going to continue to happen. That energy has not gone away. I fully expected to see something big happen today. Today's not over yet. Tomorrow will come. I wonder what's going to happen. Now, in regards to all these earthquakes, and they're still happening, yes, I am going to show you the earthquakes on the USGS map, only because they're the largest that are on the map today. What we have here is a picture of the sun taken by a telescope. Look at all the epicenters for solar flares. These are sunspots. Sunspots. Yesterday we had 10 CMEs. 10 CMEs. M-class flares launching from the sun. 10 of them. When I first saw it, it was 4. We had a total number of 7 to 10 within a matter of hours. 10 CMEs yesterday. Folks, it's a big deal. Because guess what? The 13-hour data here shows a planetary K index of 6.0. We've seen higher than that. But this is still very important. Because what is happening? The solar flares are causing earthquakes here on our planet. Big earthquakes on our planet. How does that happen? For those that are brand new, let me explain this at least one more time. The solar flare gets launched from the sun. There is proton pulse radiation coming from the sun, racing from the sun, anywhere from 600 miles per second, racing from the sun. We've had higher. We've had 1,000 to 1,100 miles per second. That was huge. But these were 669 miles per hour, or miles per second, I'm sorry. 669 miles per second. Cooking. That plasma radiation hits the Earth. What happens? The plasma radiation goes through our magnetosphere that is supposed to be helping to protect our Earth, trying to slow down the radiation and the amount of radiation that we normally would have. But because we were in an extended solar low, now we're in a solar maximum, but we had been in a solar low, and our magnetosphere deteriorated during that solar low. Now the solar maximum is supposed to be building it back up, but it has not done that. So that plasma radiation is entering the Earth's atmosphere and hitting the surface of the Earth in greater amounts. It's heating up the plates of the Earth where the earthquakes are. Now, as I have shown you this in the past, I've referred to the Cascadia subduction zone that's off the northern coast of the United States and Canada, where the Pacific plate is subducting underneath the North American continent, underneath Canada and the entire west coast of the United States and down into Mexico. The Pacific Plate is taking a super deep dive into the center of the Earth. What usually holds those plates in check where they don't move? There's a bunch of dirt and grime and biological material that's down there at the bottom of the ocean, right? Oh yeah, a lot. But all that junk and grime down there that holds those plates in place gets heated up. And when it heats up, it turns into a greasy oil type substance, and what happens? The plates slip more freely, don't they? And that is what has happened during the past, I want to say 72 hours. The past 72 hours. And it's huge. That's huge. Miley is asking how the solar plasma is affecting the South Pacific anomaly. It's heated up the plates, just like I just got through telling you. It's heated up the plates. And heating up the plates, it turns all that biological gunk that's down there that holds those plates in place, all that stuff turns into a greasy, oily substance, allowing the plates to slip more easily. Then we have an earthquake. That's what's happened. That's what's happened. Hurricane Heather says, I'm waiting for my phone to start acting up. Mine has been acting up since later last week. Actually, it was earlier last week. This time last week, my phone started playing games, and it's worse now than ever. That can happen. Electronics get screwed up. Satellites get screwed up. Air-to-ground communication between NASA headquarters in Houston and in Russia and at the space station. Communications get screwed up. Data transfer between the space station and the ground gets played with. Data transfer to and from satellites gets played with. Voice and data communication on ham radio gets played with. Voice communication with shortwave and ham radio gets played with. And in some cases, there's total radio blackouts. This also occurs with police and fire and medical radio systems. It's huge. And yes, it did happen. Even our fire department here locally had problems during the past week because of solar flares. Oh yeah. Oh yeah. There's a lot of it. PJ said, I have had headaches and ringing in my ears non-stop. I have had really bad headaches, and I still have a headache now. And before I came on the air, I took 2 Tylenol because it got bad. It still is. I don't operate as quick and easy when I have these bad headaches. None of us do. It affects all of us. Demon Catman says, yes, my tendonitis is extra horrible with the solar weather. Yeah. Oh yeah. Richard Smith says solar wind speed 571 kilometers per second now. That's now. Isn't that unreal? It really has not slowed down that much. It's crazy. It's crazy. Ken's always saying this is crazy because I've been having headaches too. I never have headaches. Guys, I never used to get headaches. I never used to get headaches before this past year. Then all of a sudden out of nowhere, I get bad headaches. It affects all of us. Heather says she's feeling a little seasick. Oh yeah, that's all part of it. I've also felt that literally all day long today. As I was trying to wake up, I felt that same way. That's what happens when we have these strong solar flares like we've had. Fortunately, this weekend they've been M class. Yes, we've had some X class, more powerful solar flares. X1 and X2 solar flares. Heaven forbid we would have an X10. X10 is the most powerful. X10 would probably fry our electronics. X10 would probably fry our electronics. Just saying. Okay? Demon Catman says he's also felt wobbly today. Oh yeah. It's incredible, guys. That's what happens here. And I'm not going to play it down. I'm not going to play it up any more than I'm doing, but I'm just saying, guys, be careful. Watch how your body is reacting. Watch what happens with all these earthquakes and other things that we're going to be talking about tonight, because it does affect all of us. It affects all of us. Look at this. This was a picture that I picked up yesterday. Those bright, shiny areas are the sunspots where solar flares launch out. And yet look over to the bottom right side of the sun here. The moon was partially eclipsing the earth and the sun yesterday. Right on the bottom right side there, just before what we call the terminator, the edge of the sun. That flare right there didn't stop yesterday. That's where most of the solar flares, the CMEs that were launched yesterday came from. Almost a direct hit on the earth. And those dark areas are solar sunspots that have already launched from the sun. The black areas are already launched from the sun. Okay? It's not going to stop. Look at those on the left that are coming back around. They're hot over there. You see the bright light over on the right, on the left side? Soon, those are going to completely face the earth. There's a lot more coming. There's a ton of them coming. Okay? Be advised. I believe it's going to get a lot worse. Okay? I think it's going to get a lot worse. Now, with that said, yesterday, one of the large earthquakes that hit the earth was just in the lower part of the Cascadia subduction zone. Lower part of the Cascadia subduction zone, right directly off the coast of Northern California. Right directly off the coast of Northern California. Now, I'm going to keep this up here, but I'm also going to show you a picture. I'm hoping to show you a picture just a second. Just a second. I am going to show this to you. Okay, it's coming. Okay, you've seen where this is. Directly off the coast. It's in what they call the Triple Junction area. The Triple Junction area. Okay? Now I'm going to move this earth of ours, or this country of ours, the United States, over to the west. I want to show you something. Because it's not stopping. It's not stopping. The first thing I'm going to show you is where that earthquake was yesterday. See where all three of these lines come into conjunction? The three earthquake faults. That earthquake fault you see going north in the red, that is the Cascadia subduction zone. It runs up the coast from Northern California all the way up past Oregon, Washington, up along the coast of British Columbia, Canada, all the way up to Queen Charlotte Island. Let me back this up and let's show you that. All the way up Oregon, all the way up here past Washington, all the way up here along the coast of British Columbia, Canada. Look at that. And all the way up here to Queen Charlotte Island. Okay? Where it meets up with another part of the Cascadia subduction zone region called the Juan de Fuca Fault. That's the zigzagged line you see there, the Juan de Fuca Fault. Okay? We're not going to talk a lot about that tonight. That's going to be another discussion another day. But right here, in the southern portion of the Cascadia subduction zone, this area here is called the Triple Junction. This is where that 5.54 earthquake was yesterday. Right here at the junction of the Cascadia subduction zone and the San Andreas Fault here. Isn't that interesting? Okay? Isn't that something? The Cascadia subduction zone meets up here with the San Andreas Fault. And the San Andreas Fault runs all the way through California, down into Mexico, down through the Gulf of California, and all the way down the western side of Mexico. That's where we had the 5.54 earthquake yesterday, right at that junction. Look what's happened just west of there. Okay? This is another earthquake fault here. This is a 2.9 earthquake west of where we had that earthquake yesterday. Could be considered an aftershock. This right here is a 3.1, a little bit stronger earthquake. I think it's very concerning what happened. I don't think it's over. Just a few months ago, just a very few months ago, some of you may have heard that the USGS told us that there was a 6.8 earthquake off the coast of Northern California. Right about here. That 6.8 was not a 6.8, it was an 8.0. That 6.8 was a good distance off the coast. If it had been a 6.8, we would not have had the damage we had on land in California. Toscana got hit. Rio Del got hit. Ferndale got hit. And Petrolia got hit. Ferndale is right about here. It got hit. Toscana is right about up in here, in the center of your slide here. Rio Del is over here. And Petrolia right here. This is Petrolia, guys. It all got hit by an 8.0 earthquake. Yesterday's 5.5 did not do much damage at all. It rattled some nerves on land, but if this had hit the land, if that 5.54 had hit the land, there would have been a lot of damage. Possibly people dying and people being injured because it was a mid-range 5. Large earthquakes come in the tune of 5.0 to 5.9. Yesterday's was a 5.5. That was a very powerful earthquake yesterday, but it was offshore. Yes, it rattled some nerves over here on land. It could have been worse. Okay? And we've had one minor earthquake and one small one. The minor earthquake was this 2.9. 2.0 to 2.9 are considered to be minor earthquakes. Knowing the USGS, the 2.9 may have been a 3.1 or 3.2 because they downgrade them. We've caught them downgrading them. This one here was a 3.1. That could have been a 3.2, 3.3 earthquake, but they're small. 3.0, 3.9 are considered to be small earthquakes. This small and minor earthquake were not even felt on land in California, but that 5.5 was. Interesting how that happens, isn't it? Okay? We're getting a lot of earthquakes. A lot of earthquakes. And it's not going to stop. It really isn't going to stop. Now, we see the San Andreas Fault running off the coast of Northern California. Yes, that's what happens. It comes off where it meets up with the Cascadia subduction zone, and it comes down here along the coast. Then before it gets to the San Francisco Bay area, it starts going inland. Okay? North of there, Willits, California. We have a 1.7 earthquake here. That's a tremor. It's on a different fault. This one here is a 1.5 in Talmadge, California. Nobody felt either of those. But we come south. See all these earthquakes? They're all tremors. Those are all tremors, 1.0 to 1.9. There might be a 2.0. Let me just check. No, that was a 1.72. This up here is 1.1. Folks, these are all just tremors, minor tremors. They're not felt. Okay? But what is this? This is a geothermal area where man has drilled into the crust of the earth. The crust is what we walk on. The crust is anywhere from 35 to 39 miles thick up to 69 miles thick. But man has drilled into the crust here to obtain steam from a volcano that's just north of there, right here. This is the Clear Lake volcano. The Clear Lake volcano. Men have drilled into the crust of the earth down into the upper magma chambers of the Clear Lake volcano to obtain steam to power turbines here. There are 80 different turbines here. This is called the geysers. These are called the geysers. 80 different turbines all over this area, guys. 80 different turbines, literally all over the landscape. This is one set of turbines. There are 8 turbines in this row here. There are a total of 80 of them, all over the mountainside here. Okay? Literally all over. And those turbines generate electricity. They generate electricity for 5 different electric conglomerates, including Pacific Gas and Electric. And Rocky Mountain Power, providing power to Utah, where I used to live. I used to pay a power bill to Rocky Mountain Power. Unreal. But 80 different turbines in this geysers complex. Look at there. There are 6 different turbines in each set here. That's huge. But these earthquakes are a direct result of all the holes in the earth that man has dug in here to pull steam out of that volcano. Seismic energy finds these holes. And when it hits these holes, it fractures the rock at those holes, causing the earth to shake. That's why we have earthquakes here. Look at those earthquakes. And this is an everyday occurrence. Most of the time, they're anywhere from 20 to 25 tremors and or earthquakes here in this area. I have counted as many as 60. And some of these times, it's been upwards of a 4.5 magnitude earthquake right here in this complex. Okay? Now, they pulled steam out of this volcano. Guess what, guys? Every volcano is recharging. Every volcano is waking up. Just a few months ago, we had a 4.5 earthquake here at Clear Lake Volcano, right here along shore of this lake. And some might ask, why do we have water on the top of these volcanoes? Because, guys, after the volcano stops erupting, there's a plug at every volcano. In this case, the lava was down inside the rim of the volcano, and that lava hardened. The lava hardened, And then the water table came in, and rain and snow came in and melted and flowed into that lake. Can you imagine what's going to happen when this volcano one day erupts? And no, it's nowhere near ready to erupt. We've only had a handful of earthquakes here at the Clear Lake volcano, at the volcano complex itself, not to including the geysers complex. We're not even talking about that. We're just talking about earthquakes at Clear Lake volcano. You don't see any earthquakes there. There are tremors there that USGS is not going to show to us. Go figure. Okay? But it's nowhere near ready to erupt. We have other volcanoes where it is erupting. All those red spots here, these red dots, those are brand new earthquakes. Brand new spanking earthquakes. There's 5 new earthquakes here that just happened within the last 45 minutes. Just saying. Okay? Anyway, the San Andreas Fault runs just alongside the west side of San Francisco Bay. Then just past San Francisco Bay, the San Andreas Fault turns inland. On the eastern side of San Francisco Bay, and I've just lit this up in blue, this is San Ramon, California. This is an entirely different earthquake fault. This is a Hayward Fault. The Hayward Fault. South of San Francisco Bay, approaching Monterey Bay here, we have a 1.4. This is Seven Trees, California. Seven Trees has gotten hit a lot lately. This is only a 1.4 tremor. They've had 2.5 earthquakes here recently. Then further south, also on the Hayward Fault, we have this 1.2, and we have a 0.7. San Ramon, California. In this case, 4 miles east-northeast of San Ramon. Really? This one is in Seven Trees. This one is in San Ramon. East-northeast of San Ramon. Now, you can also see another earthquake fault to the east, running parallel to the Hayward Fault. That's the Calaveras Fault, together with the San Andreas in this near location area. 3 of the most deadly earthquake faults in the world are right here. Isn't that interesting? And then they continue to converge. They continue to converge down here, which makes the Hayward and the Calaveras Fault very dangerous. 2 major earthquake faults converge right down here. The San Andreas Fault, like I said, continues to cut through California, moving further and further inland. Down here, this is a 1.0 at Parkfield, California. Parkfield, California is the earthquake capital of California. More earthquakes here than anywhere else, literally in California. Down here, south of there, this is Cholame, 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 California. Also a 0.9 microquake on the San Andreas Fault. Then we continue south and we don't see any more earthquakes listed. That does not mean they didn't happen. USGS will rarely even tell us when something does happen. Now, the San Andreas Fault runs down here and runs into another fault. This fault, ladies and gentlemen, is called the Garlock. The Garlock Fault meets up with the San Andreas and runs east-northeast. Here on the Garlock Fault. This is Tehachapi. Now, they're calling this a quarry blast. This might, in fact, be a quarry blast because there's a quarry south of there. Okay? This could be a quarry blast. But folks, we've had plenty of instances or events here where that seismic energy hit and there was no quarry blast. USGS may have called it a quarry blast, but it wasn't. I'm just telling you. Because just north of there is that Garlock Fault. And the Garlock Fault continues to run northeast here. Okay? It runs northeast here. And it runs northeast until it gets up here. What is this? This is the Mojave Desert. This earthquake I just highlighted for you, that is Searles Valley. Searles Valley, S-E-A-R-L-S. Okay, Searles Valley. L-E-S. S-E-A-R-L-E-S, Searles Valley. A 1.4 tremor. Right here. This is Ridgecrest, California, where we had a 7.2 magnitude earthquake hit here. Almost 4 years ago. Nearly 4 years ago. July 4th, 2019. I remember where I was because someone near me was wondering why I was checking my phone. And I just got through telling them there had just barely been a major earthquake in Southern California. Right here at Ridgecrest. Okay? Today there was only a 0.9, 1.1 magnitude earthquake. Again, I'm not calling it a 0.9 a 0.9. I'm not going to let it stay. Because the USGS downgrades earthquakes to the nearest 0.9. In this case, they downgraded it to a minor microquake. This may have been, in all actuality, a tremor. A 1.0, 1.1 tremor in Ridgecrest. The same location where we had a 7.2 earthquake 4 years ago. All over this expansive area in the Mojave Desert. This was cluttered with earthquake after earthquake, tremor after tremor. Before and after the 7.2 hit. At one point, there were over 10,000 earthquakes all over this area. 10,000. We are still seeing aftershocks today. Every one of these quakes, I believe, is an aftershock from that quake. Further north here, this is also in the Searles Valley, a 1.3. At least that's what they're saying. It's probably Little Lake, California. Okay? Over here. This is Little Lake, California. A 1.0 tremor. Further north. This, folks, is a place called Olancha, California. O-L-A-N-C-H-A. Olancha, California. This is where the earthquakes stopped, is Olancha, California. We had 3.9s, 4.0s, and even 5.0 earthquakes here at Olancha. Before and after the Ridgecrest earthquake. This is a 1.9, 2.0 earthquake here at Alachua, California today. Now, I didn't totally forget this quake here. Why didn't I talk about it? Because this is not an actual quake caused by seismic energy. This earthquake here is different. This is volcanism. This earthquake was caused by molten lava beneath the surface. This is Bonefish, California. This, folks, is an area of volcanoes. Cones and craters all over the landscape here. A 1.1 tremor here in Bonefish, California. Okay? Then the San Andreas Fault continues over towards Los Angeles. It skirts by the east side of Los Angeles. Wonderful thing. Right here we have a 1.1 tremor in Yucaipa, California. Interesting. Right here we have one in Loma Linda, California. Loma Linda, California, guys. This is the headquarters for the famous Loma Linda Medical Center. Loma Linda Medical Center. That medical center's right there. How about that? Two tremors right next to the Loma Linda Medical Center, literally. This one might be 3/4 of a mile away. That's a 1.3 tremor. This one here is a 1.2. And yet they're calling this 1 mile west southwest of the Redlands. I just got through showing you where the Loma Linda Medical Center is. It's closer to Loma Linda than the Redlands. Okay? Interesting. Then we continue going down the San Andreas Fault. This is Yucaipa, like I said. Okay? Then we continue south. This is Cabazon. All this area here is what they call the Anza Gap. The Anza Gap, including here also in Cabazon, a 0.7 microquake. This here, folks, is a 0.8 in Morongo Valley on the San Andreas Fault. Isn't that interesting? Then the San Andreas Fault continues south. Just east from the San Andreas Fault here is Coachella Valley, Coachella, California. This is a 1.0 tremor in Coachella Valley. The San Andreas Fault goes here into Imperial County, California, down near where Juanito lives. The San Andreas Fault skirts the east side of the Salton Sea here. Then it goes directly underneath the Salton Sea right here. This is called Bombay Beach. Tomorrow, or at the latest by Wednesday probably, I will come here and show you 3.0, 4.0 earthquakes happening here at Bombay Beach every day. Every day. The San Andreas Fault dropping 3.0, 3.5, 4.0 earthquakes at Bombay Beach. Okay? The San Andreas Fault goes under the Salton Sea and comes out right here. Nyland, California. And it continues to run south over to Calipatria here. Then it makes a sharp turn to the west. West-southwest. It runs down parallel to the Salton Sea until it reaches over here to Westmoreland, right here, Westmoreland, California. Then it takes another turn to the south. Another turn to the south. it runs past, having a hot flash. Okay, it runs past another town, Imperial, the town of Imperial, California. It runs past several towns. Imperial. It runs past Holtville, all this area. It runs through Heber, California, and then down into Mexico. Down through Mexico here. All the way through here. It runs east of another volcano. By the way, the Salton Sea is the Salton Butte volcano on the lower south side of the volcano, or the Salton Sea. The Salton Butte volcano on the southern side of the Salton Sea. Down here is another volcano. This is called Cerro Prado volcano. Cerro Prado volcano right here. It has a famous symbol here. Okay? A bunch of people have gone down here and put this symbol here in rock. Okay? Down on top of the plug of the volcano. And just like the Salton Sea, down in the Salton Sea, they have 6 hydrothermal areas that pull steam from the Salton Butte volcano. Down here, they pull steam from the Cerro Prado volcano, the upper magma chambers of the Cerro Prado volcano. One of those locations is right here, there. Okay? Power and turbines generate electricity. One of the other places is down here to the south. Right down here. Okay? It's a huge geothermal complex where the steam powers turbines to generate electricity here in Mexico. Okay? There are a lot of volcanoes here. A ton of volcanoes. There's an earthquake here. This is just barely south of the U.S.-Mexican border. This is a 1.8 tremor here. Not on the San Andreas Fault. This is completely different here. Completely different. There's also volcanoes up and down the entire Baja of California. Literally. And then you see that red line here. That same red line coming out of California. The San Andreas Fault, like I told you, comes down, excuse me, I'm sorry. It comes down here through the Gulf of California here. We have earthquakes here all the time. USGS is not going to tell us about them. Rarely. There have been times where there's 3s and 4.0s here caused by the San Andreas Fault, and USGS does not even identify them. But the San Andreas Fault, guys, runs all the way down here along the coast of Mexico. All the way down along the coast of Mexico. And look at that. Look here. They're not showing any earthquakes here at all. None. But there are earthquakes. Then down here, we have the Cocos Plate. Yes, folks, another plate. Another earthquake fault. The Cocos Plate is very dangerous. We're having earthquakes all over here today. And of course, the agency's not going to show them to us, are they? No, not at all. Not at all. But down here, there's another fault coming off the Cocos Plate. Folks, this is another dangerous fault. It runs right out of Guatemala here. This is called the Cayman Ridge. The Cayman Ridge. Comes out of Guatemala, then it runs just for a few miles north. Makes a quick turn to the north. Then it turns east again. It runs just south of the Cayman Islands here. Just south of the Cayman Islands here. It runs north of Jamaica. It runs and skirts the south coast of Cuba. It runs north, it runs east here past Haiti and the Dominican Republic. Yes, we have earthquakes here in the eastern part, just off the coast of the eastern part of the Dominican Republic. Okay? The Cayman Ridge, folks. One quake here. This is a small 3.7. This is a 3.4. This is a 3.8. This is a 3.8 as well. 4 earthquakes skirting the coast of the Dominican Republic. Then look here, just right next to and off of the Cayman Ridge here. Literally. There's another 3.7. There is a 4.1 moderate earthquake. 3.7 and a 4.1 moderate earthquake. Further south, a 3.4. 43 miles north-northeast of Puerto Rico. And down here, this is in the region of the U.S. and British Virgin Islands. This is a 3.3 magnitude earthquake 27 miles north of Cruz Bay, U.S. Virgin Islands. Okay? The Cayman Ridge continues east and then it takes an abrupt turn to the south. It goes east of the Windward Islands here, the Leeward Islands. Okay? Incredible. It continues south here until it takes another abrupt turn to the west through Venezuela. Through Venezuela to right in here. Okay? We've had 5.0 earthquakes here before, right in this little bay. Dropped here by the Cayman Ridge. A major earthquake fault. A major earthquake fault. Let's go back up here to Puerto Rico. We didn't talk about some earthquakes here. These earthquakes had nothing to do with the Cayman Ridge. These are aftershocks of an earthquake that hit here 4 years ago. Right after Christmas, December 26th and December 28th, we had one was an 8.0 earthquake on December 28th. 2 days later, another 8.4 major earthquake. Both of these major earthquakes, destroying homes and businesses all over this area. It killed a handful of people. Houses and businesses destroyed. People displaced out of their homes because they could not trust the integrity of their homes. Puerto Rico is affiliated with the United States of America. It's an island nation affiliated with the United States. The second earthquake, the 8.4, hit right down here. There used to be a natural arch, a great big huge arch, similar to the arches that you would find in Arches National Park, Utah. A great big huge sandstone arch came down after the 8.4 earthquake hit. It didn't come down before when the 8.0 hit, but the 8.4 did it in. Again, destroying homes and businesses all over southern Puerto Rico. Look at this big town here. This is a good-sized city, ladies and gentlemen. This is a city that's spread out all over this part of Puerto Rico. Cities and towns all over this area were hit by earthquakes, and they continue to get hit by earthquakes, aftershocks of the 8.0 and 8.4 earthquakes that struck those 2 days. The sad thing about that is, for those of you that have never tuned into this program before, let me tell you something that's really bad. Really, really bad. An organization that is supposed to be affiliated with the United States of America. An organization that is supposed to be affiliated with the government. Now, I don't know why my picture went down. That happened yesterday too. I just found that out. No picture. I'm back. Let me show you something, guys. This organization right here. Please do not put this in chat. If you put this in chat, we could lose our program forever. The platform YouTube that we're on doesn't like us talking negative about these organizations. Okay? But this organization right here caused it. That organization lit up a facility in Norway. They lit up another facility in Russia. They lit up another facility in northwestern Australia. They triangulated this area of Puerto Rico. They triangulated this area of Puerto Rico and caused those quakes. We proved it. When these earthquakes happened, we proved it. We found them turning on those facilities and triangulating Puerto Rico. We caught them. And at first they denied it. Then they had to backtrack and eat crow for a while. And then they said, oh, but we didn't triangulate Puerto Rico. Oh, no, we didn't do that. Yeah, they did. We're still having aftershocks since that happened. This earthquake here, that's a 2.0 minor earthquake. Aftershock. This one's a 2.2. This one's a 2.4. This one's a 2.4. This is Guanica, near Guanica, Puerto Rico. I have a dear friend living near Guanica, Puerto Rico. His name's Dominic. He's a captain with the Puerto Rican Police Department. Puerto Rican Police Forces. He and I have talked a lot. This earthquake is a 1.8, 11 miles northwest of Sabana Grande, Puerto Rico. Sabana Grande, Puerto Rico. Earthquakes happen all the time. This one was human caused. It killed people, it destroyed property. Incredible. Incredible. Now, You see only 3 earthquakes in all of South America. There are 25 earthquakes here in South America. They just do not want to talk about it. They don't. They do this all the time. All the time. Down here in the South Pacific, where we had all those earthquakes last week. This is the earthquake that hit over here near Hihi-Fotonga. Okay? This is a 5.1 earthquake. 21 miles northeast of Hihi-Fotonga. Okay? For the most part, the ocean water absorbed that earthquake shock wave. If anything, the people on Hihi-Fotonga and the surrounding islands over there may have gotten a little foot shuffle. Okay? They may have just felt a little bit of ground movement, that's all. When these earthquakes hit off the coast like that, the ocean water absorbs most of the quake shaking, the seismic waves. If it hits on land, that's not good. Not good at all. Over here, where you see these earthquakes, this one is in the Loyalty Islands again. This is a 5.5 aftershock of the major earthquake that hit here. We had an 8.0 earthquake that hit here. Not a 7.6 like they said. They downgraded it from a 7.8 to a 7.6, but it wasn't that. It was an 8.0. 40 times 40 times the amount of pressure. Here today we have a 5.5 mid-range 5. Still a very large earthquake. 5.0 to 5.9 is considered to be a large earthquake. 5.6 to 5.9, very large earthquake. Over here to the west, this is a 5.0 earthquake. USGS has as a 4.9. Again, they downgraded them. Not a 4.9, but at least a 5.0, if not larger. Here, also in the Loyalty Islands area, a 5.0 large earthquake. This is a 5.1 in New Caledonia. What did we have happen here this past weekend? Another set of 7s here, and 6s and such. There's a lot more earthquakes here even now, but USGS will never talk about it. Never talk about it. Heaven forbid. A 5.1 earthquake in New Caledonia today. There are a bunch of aftershocks. You'll never see them here. Every one of these earthquakes are aftershocks of the major earthquakes that hit here this weekend. Every one of them. Every one of them. Then we go further north. This is the Solomon Islands. We have a 5.3 earthquake here. This one is Papua, Indonesia. This is Aveyah, Indonesia. We have frequent earthquakes here. This happens to be a 4.5 earthquake. This is 28 kilometers deep. Let's go back to these earthquakes here and find out how deep they are. This is a 5.1 in Tonga, 24 miles deep. This one is a 5.5 in Loyalty Islands again, 19 miles deep. This one happens to be a 4.9, 5.0, 6 miles deep, 10 kilometers deep. This one is a 5.0, also 6.2 miles deep, 10 kilometers deep. And this one here is a 5.1, also 6.2 miles, 10 kilometers deep. Okay? Solomon Islands, 6.2 miles deep, 10 kilometers deep. We go over here to central Indonesia. Okay? This happens to be a 4.3 aftershock, 6.2 kilometers deep here in Indonesia. This happens to be a 5.2 earthquake. It's a large earthquake that caused that aftershock. This happens to be in the Molucca Sea here in Indonesia. Again, we have to tell you, this was not near land. The ocean waters absorbed the shock waves of this earthquake. Nobody on land probably even felt anything here. Nothing. Now, these are not the only earthquakes here. It's only the earthquakes that USGS wants to tell us that's here. Okay? They just want us to believe that's all. Now, I'm going to show you a lot more. I'm going to show you a heck of a lot more. Okay? No, I haven't been on the air since Friday. There's a lot of stuff to talk about. A lot of things to talk about. Look here, guys. Look at all the earthquakes here. They'd like you to believe that nothing happens here. That's a heck of a lot of earthquakes. And folks, no, they're not 5.0s. They're 4.2s and 3.2s and such. Moderate and small earthquakes all over this area. All over. And remember that 5.0 I just got through showing you? Remember that I just got through showing you? No, I'm sorry, it wasn't 5.0, it was a 4.5. A moderate 4.5. Okay? USGS would have us believe there's one earthquake. There's three. This is a map of the European agency, the EMSC. Okay? This is a 3.7 small earthquake. This is a 4.5. Right here is a 3.3. Three small earthquakes. Look at the fault zones, guys. There's 7 different fault zones here. There's 7 different fault zones all over this area. 7 different faults, one subducting underneath the other here in the Indonesia, Asia Pacific area. 7 different fault zones, one going underneath another and another and another. This, folks, is probably the world's, this, folks, right here. This probably is one of the biggest fault zones in the world. Between Tonga, Fiji, Loyalty Islands, New Caledonia, the Solomon Islands, this whole area, going down to Australia, into Indonesia, this whole area, and also the Philippines, one of the largest fault zones in the world. And someplace else also that they did not tell us we had an earthquake. I have a lot of friends here. I have a lot of friends here in Australia, right down here. Right down here today, we had an earthquake. This was a 2.0 near Boronia, Australia. A 2.0 near Boronia, Australia. Now, folks, I've only seen one earthquake in 4 years. be displayed here in Australia. One earthquake in 4 years. That earthquake struck right here. It was a 6.2 earthquake here 2 years ago. The only reason USGS put it up, because it was a very strong earthquake. A very strong earthquake. Okay? They've had earthquakes off the shore, off the western shore of Australia. Yes, they've told us about them, but guess what? Each and every one of them has either been a large or very large earthquake. Every one of them. This one right here, there was an earthquake here about two and a half years ago. It was a 6.3 very strong earthquake off the coast of Australia here. Some of it was felt out here, over on land. Because, folks, it was in the ocean. However, the strata where it hit, the rock base where it hit, was very strong. So the seismic waves radiated all the way over here to the east, here in Western Australia. Another one further north right here was a 5.0, just barely offshore. Yes, there was some damage to people that lived out here, to their homes and such. Okay? It doesn't happen very often. It doesn't happen very often at all. But when it does, look out. Now I'm trying to find something here. No, that's not it. It's hard for me to find here on the USGS map. There's one of the locations that lit up that helped cause that earthquake in Puerto Rico, and it's up here in northwestern Australia. That location here in Australia helped set up those earthquakes in Puerto Rico. Okay? But I can't find it here. When I do, I will show it to you. But over here in the Valdese, a 4.3, and a large earthquake than that, a 5.1. But you don't see too many earthquakes being located here by the USGS. They will never tell us the truth. Never. Not on my grave or yours. This is Tobelo, Indonesia, 4.5. Further north, this is in the Philippines. There's probably 15 earthquakes here in the Philippines they're just not talking about. Okay? It's sad. It's sad. Right here. A moderate earthquake. Some people felt that. Pictures falling off of walls. Knickknacks and books falling off of shelves. Plates rattling. Okay? This earthquake here, north of Taiwan. This is in the Ryukyu Islands of Japan. This is a 4.2 in Tarama, Japan. Over here, off the coast of Honshu, Japan. Okay? We had another large 5.1 here. Okay? Near the coast of Honshu. This was an aftershock. There were 4 aftershocks that are showing us one. Why? Because this is also a 5.0 earthquake. They're calling it a 4.9. So we had 2 5s here. Right here. Off the coast. Probably nobody felt those because they were far enough off the coast. But there were other earthquakes here as well. Let me show you that real quick. Then I promise we're going back to Cascadia. I can't wait to show you this, guys. This makes USGS look disgusting. They're showing us 2 earthquakes. How about this, guys? 20 plus earthquakes. 20 plus earthquakes. They're showing us 2. 20 plus earthquakes, guys. What is wrong with them? Yes, they're all offshore. These are all offshore here. 20 plus earthquakes offshore. And yet they will never tell us about those. Never. 20 plus earthquakes offshore. Offshore from Honshu. From Honshu, Japan. How about another earthquake offshore from Hokkaido? Just barely offshore from Hokkaido. That's a 4.0. Okay? That's a 4.0. How about another earthquake just south of Kyoto? This is a 2.3 near Toshima, Japan. In the water south of Japan there. Okay? 20 plus earthquakes in Japan. And they show 2. Okay? Now, this earthquake I'm going to show you because it just happened. This is in the Sea of Okhotsk. This is over on the western side of Kamchatka Peninsula. It's a 4.3 magnitude earthquake here in the Sea of Okhotsk. See that earthquake fault coming out of Japan, running up here and going along the east coast of Kamchatka? And there's an earthquake right there on that earthquake fault. But over in the Sea of Okhotsk, we don't see too many earthquakes there. There may be more because Russia just doesn't want us to know about it. Okay? We don't see a lot of earthquakes in Russia or China. This one here off the east coast of Kamchatka was a 4.0. Okay? Now, look at Alaska today. Look at Alaska today. There's like 40 earthquakes in Alaska. 40 earthquakes in Alaska. This bothers me to no end because there's a lot more earthquakes. Not even the Europeans are showing them. This is one of the fewest days where I've seen the fewest earthquakes in Alaska. There was one day last winter, where they showed 20 earthquakes in Alaska, and I said, bah humbug. There's a lot more. There are a lot more. Now, some of you have talked about earthquakes in Hawaii. Last Friday, we showed you seismograms showing all of the earthquakes hitting in Hawaii. Now, get out my pen to point out earthquakes. These earthquakes right here, it says 10 plus. This is Pahala, Hawaii. This is where the magma from the big, huge plume of magma in the South Pacific, that plume of magma in the South Pacific supplies magma to all the volcanoes all around the world. The plume comes up here to the big island. This is Pahala. Then the magma is distributed to the 4 different volcanoes all around the island. Now we see 20 plus earthquakes here near Kilauea. 20 plus earthquakes near Kilauea. Guess what? There's new volcanic activity at Kilauea. You see 10 plus earthquakes up here. Okay? This is southwest from Kilauea. Let's take a look at this. Okay? Right here on the outskirts of Kilauea. So actually what we have here is about 34 earthquakes here around Kilauea. 34 earthquakes around Kilauea. Okay? That's just part of them right here. There's a lot of earthquakes hitting the Big Island. A lot. Over here, I showed you this Friday. This is Mauna Loa. Up here is Mauna Kea. Over here is Hualalai. I showed you seismograms on Friday. You can go back to our Friday program and see that there's swarms of earthquakes there. The agency doesn't want you to know about them. They want to keep them quiet. They don't want the people to know about it. Unless you're looking for the earthquakes, you're not going to find them. The earthquakes show up on the seismograms. Heaven forbid they put them up on the map where people can see them. Those volcanoes are moving, guys. Those volcanoes are moving. Let there be no doubt about it. The volcanoes are moving. Look at this sorry example of what USGS is showing. I just got through showing you the European agency. It's sick. The USGS would have us see nothing. Almost nothing. Folks, there are over 40 earthquakes caused by magma activity on the Big Island. 40 plus earthquakes. And they're not even showing half of them. And there's more earthquakes up here in the volcanic areas. Mauna Loa, Mauna Kea, and Hualalai. Sad. Sad. Folks, this is terrible. This is terrible. Twizzles said you need to check before each show begins. What do I need to check, Twizzles? Let me scroll back through here and see if I can see what you're talking about. Hurricane Heather's talking about a typhoon, Mawar, that is off the coast of Guam. Folks, let me show you something real quick. Let's get out of this USGS map. I want to show you that cyclone. This is Marwar. Okay? This is over in the Western Pacific, just south of Guam. It's scheduled to hit Guam as a 140 plus mile per hour hurricane. They call it a cyclone in this area of the world. 140 miles per hour. That's nearly a Category 5 hurricane. Look at the well-defined eye. This is going to be a very powerful storm. This is a very powerful storm. My buddy Rob says that, wow, there's happened a lot of earthquakes happening. Yeah, there are. There's a ton of earthquakes happening. Okay? Twizzles is asking what was what. You said I need to keep an eye on before I come on the air. I try to keep my eye on everything. Craig Medlots is giving us a $10 super chat. Thank you for that. I really appreciate that, guys. These super chats and the donations you send to Venmo and to PayPal and through our post office, that means a lot to us. It helps keep the lights on here. It helps keep us plugged in to high quality bandwidth so we can do this program. I found out quite quickly you have to have good bandwidth to go on the air here. Otherwise you're not going to make it. You have to have a lot of bandwidth. I appreciate your helping me. Okay? Some of you have also helped me since I got sick with cancer. You've helped me pay my bills. I've got about $2,000 more to go. But you helped keep the doctors off my back. I still have them on my back, but not as bad. I really appreciate all your help that you've been giving me. My cancer is in remission, and I'm now 6 months out of cancer treatment. So that's good. I hope I can stay there. I appreciate all of you helping me with that. But this is Cyclone Marwar that's off the coast of Guam, and when it hits Guam in the next day or so, it's going to hit with 140-mile-per-hour winds. It's huge. It's huge. Something else that I want to talk about tonight. Over in Sicily, just south of Italy, we have another volcano that's erupted again. Mount Etna erupted very strongly. Okay? About 20,000 feet into the air, throwing lava bombs all over that area, ash going up into the air. The major city, Catania, has been covered in ash. The local airport there in Catania has been closed off and on because of the ash there. Molten lava is flowing down the sides of the volcano. Okay? That's in Italy. There are many volcanoes erupting. This is just one of the worst. One of the other volcanoes that's erupting over in southeastern Mexico. This is southeast of Mexico City. A very powerful eruption at Popocatépetl today, throwing lava bombs down the mountain, threatening the little towns around the circumference of the mountain, prompting evacuations all over. Huge. This is huge, guys. All over the place. Let me tell you about Mount Etna real quick. No, I'm sorry. Let's talk about Popocatépetl. Popo woke up yesterday again. There's been very powerful eruptions at Popocatépetl, but today's was probably the most powerful. Mexican authorities said yesterday morning the warning level at Popocatépetl volcano is one step before a red alert, as smoke and ash and molten rock spewed into the sky, posing risks to aviation and far-flung communities below that. The volcano, located in central Mexico, is considered to be one of the most dangerous volcanoes in the world because some 25 million people live within 100-kilometer distance, 60-mile distance. Sunday's increased alert level to condition yellow, phase 3. Condition yellow is a cautionary alert, but this was phase 3, where we have molten lava cascading down the sides of the volcano and molten rock being thrown into the air. Comes a day after 2 Mexican City airports were closed, temporarily halted operations due to falling ash. Popocatépetl is located on the borders of the central states of Morelos, Puebla, there are 3 of them, I thought. Morelos and Puebla at least, the capital of which an AFP reporter said Sunday that he got woken up by the blanketing of gray ash on his home. The yellow warning level means remain alert and prepare for a possible evacuation. That's according to the warning system developed by Mexico's National Disaster Prevention Center. The yellow phase 3 activated Sunday means intermittent to high activity and is triggered when the volcano shows explosions of increasing intensity, expelling incandescent fragments. That's according to Civil Protection Coordinator Laura Velasquez. The alert increase also means an elevated risk of spewing magma and significant explosions of increasing intensity that shoot fragments of rock over considerable distances. The next stop, a red alert that triggers mandatory evacuations. Dozens of shelters all over that area have already opened in areas surrounding the crater. Popocatépetl has not had a massive eruption such as this in more than a millennium. Yes, they've had eruptions, but not like this. Popocatépetl became active in 1994. It's seen periods of increased activity ever since. And again, Mount Etna erupted again. Mount Etna erupted again, and today's eruption was huge. It was really huge. Okay? Now, I wanted to talk to you about Cascadia. Okay? Cascadia is an unusual area. Okay? I'm just telling you. It's a very unusual area. We have a lot of volcanoes there. We have a lot of volcanoes in the Cascadia area. Plain and simple. Okay? That has always been the case. Okay? The Cascadia area, guys, has been very active for like 400 plus years. Very active. And this is just one of them. Over 200 years ago, we had a major earthquake there. It was called the Cascadia earthquake. And it's been going for a long time. The seismic energy lasted days and days, and I believe they even said weeks. Okay? Weeks. The Cascadia area is this area that I'm showing you here. It runs from down here in Northern California, where I showed you those earthquakes earlier in the program. Runs all the way up here to just off the coast of British Columbia, Canada. Now, the earthquake we're talking about, the Cascadia megathrust earthquake, scientists believe, the majority of the scientists believe, it's going to happen here, just off the coast of Seattle, right here in this area. This is the Cascadia subduction zone, this red line here. Further west, I showed you this earlier too, this is the Juan de Fuca fault. Somewhere between the Juan de Fuca and the Cascadia earthquake faults. It's where this Cascadia megathrust earthquake is going to happen. The last time it happened, there was a mariner out to sea off the coast, and he said that it was either Mount Rainier or Glacier Peak that was erupting. Glacier Peak is north of Seattle, about 40 miles north of Seattle. That mariner, that captain of the boat off the coast, said it was either Glacier Peak or Mount Rainier that was erupting at the time. Today we have one earthquake over here on Vancouver Island. This is a 1.1 tremor near West Duncan, Canada. Just 7 miles, just over 10 kilometers distance. Okay? That's the only earthquake here in the Cascadia region, stretching from southwestern British Columbia all the way down to Northern California. When I'm talking about earthquakes and such, I'm mostly going to talk about earthquakes here in the mountainous areas, the Cascade Mountains, the volcanoes and such. Okay? Right here, we see Mount Rainier right there. You don't see any earthquakes here, do you? Further south here, this is Mount St. Helens here. You don't see anything here either. Further to the west, to the east, we have Mount Adams right here. Well, guess what, guys? I have seismic activity here at Adams. There's a lesser volcano known as Cedar Flats right here. Right there. There's activity at Cedar Flats as well. Isn't that wild? Further south, Mount Hood. We have seismic activity here at this volcano too. We have also got volcanic activity happening at other volcanoes all the way down to south central Oregon and going into northern California in terms of Mount Shasta and Mount Lassen. Now that's what I'm going to show you right now. Folks, there is a lot of activity. There's a ton of activity. This normally happens. Normally happens. Usually it's not any surprise to anyone because this activity's been happening for a very long time. Now, first off, I'm going to go up to Mount Rainier. I'm going to show you Mount Rainier first. I'm only going to show you maybe one seismogram from each of the volcanoes. This is Mount Rainier, guys. Most of this is all tremor activity, but you can see there's larger earthquakes here as well. Larger meaning 2.2 and larger earthquakes. These here earthquakes that you see here that are long vertical lines, they're maybe a half inch, 3/4 of an inch long here. These are 2.0 earthquakes. If you see a vertical line that does not have a dot in the middle of it, that is steam. That is steam coming from the volcano. Look at all these earthquakes. That earthquake in dark blue right there, that's a 2.2, 2.3 earthquake. Okay? Look at this earthquake here in the center of your screen here. This, folks, looks to be a large earthquake. Why? Look at the lines going through it. And look how long the earthquake lasted, and I mean the time element. This earthquake here lasted a good minute and a half. Here, it would seem to be a 2.0 earthquake. But folks, this seismograph, the machine itself, the seismograph, has been turned down. This may have been as much as a 3.0 earthquake if it wasn't turned down. This earthquake in dark blue to the right, this appears to be a 2.2 magnitude earthquake as well. But look at the depth of it. How long did it last? Nearly 30 seconds. Those lines going through these earthquakes, that is rock fracturing. The magma coming into the magma chamber of this volcano comes in under pressure and it fractures the rock. Okay? And yes, please, guys, please give us thumbs up if you like what we're talking about tonight. We've given you a lot of information tonight already. Okay? And yes, now we're over 2 hours here. And I'm sorry about that. There was a lot of information that I had to give you tonight. A lot of stuff happened during the weekend. Okay? That was Mount Rainier. Let's move south. I want to show you Mount St. Helens next. I'm going to show you Mount St. Helens here. This is East Dome Mount St. Helens. This is Dome of the Rock at Mount St. Helens. Okay? Look what we see here. Again, this is a USGS seismogram. It's in blue. If you see a red seismogram, it's a Pacific Northwest Seismic Network. Well, guess what? Pacific Northwest Seismic Network shut down all their seismographs. All of them. East Dome, everything. USGS said they get their information from the Pacific Northwest Seismic Network. Really? Really? Well, guess what? This is East Dome Mount St. Helens. We have an earthquake at the top of this. Okay? At the very top, this was last night. The seismograph started recording this seismogram at 10 p.m. last night. Okay? 10 p.m. last night. And instantly we get at least a 2.0 magnitude earthquake. Why do I say at least? Because this looks to be a little bit bigger than a 2.0. Also here over on the right, in the lighter blue here, that sideways rectangle is called a magma churn signal. When superheated magma comes into this volcano, it creates a magma churn signal. Magma churn signals are typically 23 to 24 lines high. This one is 1, 2, 3, 4, 5, 6, 7 lines high. That means it's only 25 to 26% of real world. Okay? So this seismogram is only showing you 25%, maybe 25, 26% of what it really should show. So this 2.0 earthquake could have been a 3.0, 3.5 earthquake. Again, we have another earthquake here that was showing early this morning. What is it? This happened just after 4:45 this morning. Okay? This is about 3.5 minutes after that. So this would be 4:48. Okay? It's another 2.0 earthquake. Folks, this may have been a lot larger earthquake as well. Look here at all this magma here. Look at all the magma coming into the volcano here. Each of these lines represents 15 minutes. Each of the horizontal lines here represents 15 minutes of time. That's what magma is coming into the volcano on. Each of these lines shows you the amount of magma coming into the magma chamber. Now imagine if this seismograph had been turned up 100 to 100%, fully operational at 100%. We may not see any white on this paper here. There may not have been any white at all, because there was so much magma coming in here, it would have obliterated the background white. Okay? That's a lot of magma. Okay? Then just below that, just below all that magma, all of a sudden you see a vertical line again here. A vertical line with a curlicue. That is an official steam signal. Steam signal. You also have one here on the right-hand side, just below that magma. That is a steam signature. Sometimes when the seismograph has been turned so far down, all you see is tiny vertical lines. Those are steam, if it does not have a dot in the middle of that vertical line there. And here's another steam signature here, not a steam signature, a magma churn signal. And those lines onto the right of this one and the other one, those are steam lines. Steam coming from the magma. Steam coming from the magma. And Mount Rainier is steaming. Mount Rainier is definitely steaming. Somebody asked me that question a while back. Okay? I want to show you something here. Okay? Just real quickly. If you will allow me to do it. Okay? I want to show you something here. Okay. Give me just a second. Okay, let me see where to go. I want to show you a picture of Mount Rainier steaming. A lot of people question it. And you have a right to question it. You always have the right to question it. I have no problem with that. Are these volcanoes really steaming? Yeah, you have the right to question that. Always. Always. But I have some things to show you here. Okay, look at this, guys. Look at the steam that leveled out over the volcano. This is not a cloud. This was steam, and you can still see a layer of steam rising from the summit of Mount Rainier. And some places I have even better pictures of it. But that's Mount Rainier. I want to show you something quickly over at Mount St. Helens, because I'm going to show you Mount St. Helens next. Where to go? I know I have a picture of Mount St. Helens going. You've all seen pictures of Mount St. Helens erupting in 1980 and also in I believe it was 2006. But someplace here, I believe I've got one of Mount St. Helens that was just steaming. At least I thought I did. Well, that's terrible. That's weird. I guess I don't. I don't have one of Mount St. Helens here. That's really weird. Now I'm going to have to go find it, look for it. Yes, Mount St. Helens is also steaming. Really big. Really big. Anyway, guys, these volcanoes are moving. They are. They're going crazy. Literally. Okay, hold on a second. Okay, Mount St. Helens is moving. Where did it go here? I know I usually don't sing here on the air. I don't usually sing on the air. All right. Okay. I'm back. Again, this is Mount St. Helens, guys. All that magma coming into the volcano here. Big deal. A huge deal. And down here at the bottom, you see that magma churn signal. Okay? Let's move south to Mount Hood. Actually, no. Let's don't do that. Oh, why did it do that? Just a second here, guys. Let me bring up another one here. Oh. Sorry guys, I'm usually way more organized than this. Always, I'm way more organized than what you're seeing now. Okay, I just showed you Mount St. Helens. This is Mount Adams, okay? This is the volcano that's just east of Mount St. Helens. Now I'm going to open this up so you can really see it. Look at all this activity. This is the first time in months that we've seen a decent seismogram coming from Mount Adams, okay? Mount Adams used to show us nothing but steam and earthquakes hitting that volcano. Earthquakes from magma going into the volcano, fracturing rock inside the volcano. Here you see an awful lot of seismic activity, don't you? Look at all that. Each line here represents 15 minutes of time too. But you're actually seeing the blobs of magma and such coming into the magma chamber. Each line you see these thinner lines and thicker lines. Those are called magma pulse signals. Magma pulse, P-U-L-S-E. Magma pulse signals, meaning the lines get thinner and get thicker and get thinner again and get thicker again. Magma pulse signals, magma incoming into the magma chamber. And you see these blobs of magma. This actually happens. And you see lines going out of the blobs of magma. Those lines are caused by magma fracturing the rock inside the volcano, moving the earth, earthquakes and tremors. Okay, you're seeing it all here. Down at the bottom right hand side, at the bottom black line, look at that earthquake. It goes way down there, doesn't it? This may be close to a 2.0 earthquake. It could be just a 1.7 or 1.8 tremor. But this is a big deal at Mount Adams. I have not seen this kind of activity at Mount Adams for a very long time because the network doesn't want to show us this information. They hide it. And for the first time in months, literally, we have a full seismogram loaded with information from Mount Adams. Again, this is a big deal. A big deal. Let's go south to Mount Hood. Mount Hood is something else as well. Okay? Now, again, we're not seeing much of anything except this one seismogram here from Mount Hood. This is Timberline. This is the seismograph that is sitting on the southern lower side of Mount Hood, Timberline. Okay, Let me increase the size of this seismogram so you can see what we're talking about. Look at all this magma coming into this volcano. Okay, the top of both of these seismograms I'm showing you here in red, the top of them is 5 p.m. yesterday. 5 p.m. yesterday. And again, each line here represents 15 minutes of time. Look at that thick line of magma. Okay? Look at that thick line of magma at 7 p.m. 1900 hours on the left-hand side. It says 19, that's 1900 hours military time. Okay? That's 7 p.m. Okay? Look at all that magma. And the vertical lines, guys. Look at that. Look at the tall red vertical lines over in the center right here. Those are actually 2.0, 2.2 earthquakes. That's a lot of activity. And you can see these all over this seismogram. Earthquakes happening because of magma coming into the magma chamber here. Okay? And these little tiny lines are tremors. They're tremors. Unless we see a little tiny line without a dot in it, and those are steam coming from the volcano. And yes, Mount Hood is steaming. Mount Hood is steaming. Now I'm going to work our way south here, real quick like. Okay, I want to show you a few more volcanoes and then we'll call it a night. Okay, I'm going to go south to Sisters Volcano. Sisters Volcano. Sisters Volcano is not just one volcano, it's three. Three separate and distinct volcanoes. Okay, Sisters North, Sisters Central, and Sisters South. This seismogram starts at 10 p.m. last night at the top. You can see some activity. Most of it magma coming into the magma chamber. There are some tiny vertical lines, tremors, caused by the magma fracturing the rock inside the volcano. And then a lot of the activity slows down and nearly stops. In fact, it does stop after about 3 o'clock this morning. Then it starts up again. Now, when it stops there, where you see absolutely no activity early this morning, I believe they shut down the seismogram. Shut off the seismogram. Totally shut it down. There's nothing showing. Then they turn it on. Then they turn it on again. Look at the activity here. Look at all this magma here. Now, why am I talking it like that? Look at all this magma. They shut it down because they didn't want anyone to see the actual activity. They didn't want anyone to see all the actual activity. Look at the top of it. Very little. They had the seismograph turned way down. There's a lot of activity, but the seismograph is not recording it because it was turned so far down. Then it was nearly turned off or off. Then they gradually turned it up, didn't they? You can see it. When they turned it up, that's when all the seismic activity started happening, when all the magma starts showing on the seismogram. Understand what we're talking about? They had the thing nearly turned down, and when they turned it up, this is the activity they had. Sisters Volcanoes is righteous. About a year ago, they had Sisters Volcano on a yellow alert, meaning that they believe that it may begin to erupt. That's what they thought. But it did not erupt. The activity calmed down. Well, this is just exactly the same activity that they had when they turned the alert on, when they set up the alert. Okay? Crazy. Let's go further south to Newberry Volcano. They issued an alert at Newberry Volcano a few months ago. There was this activity just like this. Okay? Activity just like this. This is seismograph CIHL. CIHL. Look at the activity here. Look at all that activity. Magma pouring into the volcano. And it gets thicker. If this seismograph was turned up to where it should be, we may not see any white behind the color here. That's all magma coming into the magma chamber. Then they turn it almost off again. Look at that. And here, folks, down here at the bottom of the seismograph, you're actually seeing more activity again. They may have turned it up more. But you see what I'm saying here, guys? That is incredible activity at these volcanoes. This is Oregon, guys. Anything from Mount Hood south is Oregon. The next one I'm going to show you is South Central Oregon. It's called Crater Lake. Crater Lake is a wonderful volcano. It's a high mountain volcano, and there's a lake at the top of it. It's an alpine lake, meaning cold, very cold. Look at this. Look at all this magma. Okay? You can really see it here. This is probably the best description of magma at Crater Lake that we've seen in a very long time. This is the most magma we've seen coming into this volcano in a very long time. Okay? Magma infill coming into the volcano. Now, I'm going to go south across into California. The first one I'm going to show you is Mount Shasta. And then I'll show you Mount Lassen. This is Mount Shasta, guys. Look at this. There are 10 different seismographs all around this volcano. 10 different ones. I found 3 that were operational. All the rest of them have been turned off, or they put up false information. On 2 of those seismograms that showed up, they're the exact same seismogram, no different. This one shows you a lot of activity, or at least some. Okay? We're seeing magma coming in here to the magma chamber. See these red lines here? The red lines are computer generated that get the seismologist's attention to say, hey, look at this. This is important. Yes, this is a lot of magma coming into the magma chamber, and it's also causing earthquakes. Earthquakes. The light blue line here between those are actual earthquakes at Mount Shasta. And it would appear to be 2.0 magnitude earthquakes. But again, this seismograph is turned way down. Look what happens down here. More activity here. Okay, that's an awful lot of activity at Mount Shasta. Now, I'm going to show you one at Mount Lassen as well. Look here at Mount Lassen, guys. Look at this. This is tremendous activity. Again, this mountain right here, this is south of Shasta. They have 14 seismic stations all around the mountain. Only 2 of them work. Sometimes none of them work. But look at this earthquake in red. Again, this is computer generated in red. But this is significant. This is a huge earthquake. This is at least a 4.0 earthquake. And the vertical lines here, those are steam signatures. steam signatures, steam being released from the volcano. You see earthquakes here. You see a lot of earthquakes. Look at these earthquakes this afternoon. That's big time information, guys. We haven't seen this kind of activity at Mount Lassen in months. We used to see it all the time. But they've been turning these seismographs down, or they don't show any information. Plain and simple. They turn them down and shut them off. They do it all the time now. Rarely can we ever find a decent seismogram. Today we did. Does anybody have any questions? Does anybody have any questions? Sorry about that. Kimberly says she can see Mount Lassen from her house. That's cool. Kimberly, did you feel any of these earthquakes today? These were big enough you might be able to feel them. Rob has just put up our locations where you can reach our PayPal. I have actually 2 PayPal locations, one at the Hotmail location and the other over at Emergency Management Associates. Okay. I have 2 PayPal locations and I have a Venmo location where you can send us donations through there. We really appreciate that too. We have many people that do that, which I really appreciate. Tomas is also showing a 3.0 in San Juan, Argentina. That's awesome. And that happens all the time. But again, what did USGS show? 2 in northern Chile, and that's all they showed. There are a lot more than that. There are almost 30 earthquakes in South America by itself. Incredible. Anyway, do you guys have any questions here? Tomas is also saying a 3.9, 4.0 offshore from New Zealand. I'll bet. And there's going to be bigger ones because of all that activity over near Fiji, New Caledonia, and the Loyalty Islands. That's going to go south too. New Zealand could see a massive earthquake. I hope it doesn't happen. I pray it doesn't happen. Rob just put up our PayPal location at emergencymanagementassociates 691. That is our PayPal location. paypal.me/emergencymanagementassociates591. Thank you, Rob. I appreciate it. God bless you guys for it. Okay, guys, that is our story for tonight. I appreciate everybody who has come in here tonight. I appreciate those of you that came in and gave us super chats tonight. We greatly, greatly appreciate it. I see Hyde's 369 here giving us a thumbs up. A-okay, that's cool. Rob gave us another thumbs up. God bless you guys. We appreciate it. Kimberly Watkins says, Wolf Manuel, it's all part of the fun living in Northern California. I'm ready. Just have to grab one bag by my door and I'm out. She's got her go bag or a 72-hour kit right by her door. That's awesome. Everything she needs is in her car. That's the way we should be. We're going to be talking about emergency preparedness on Friday. Okay? Right now, I want to talk about a scripture. This past Sunday and the Sunday before that, we talked about the scribes and the Pharisees and the Sadducees and the lawyers trying to trip up Jesus Christ, trying to set a trap for him to get him to fail in his mission. One of the first ones was the Pharisees that tried to tangle him up. Okay? They were talking about what is lawful. They're talking about money, paying taxes to Caesar. Tell us therefore, what thinkest thou, if it is lawful to give tribute unto Caesar or not? But Jesus perceived their wickedness, and said, Why tempt ye? Why tempt ye me, ye hypocrites? Then the Sadducees got involved, and they set another trap, saying, Master, Master, Moses said, if a man die having no children, his brother shall marry his wife, and raise up seed unto his brother. In this case, the Sadducees tried to trip up the Lord by saying, one brother to the next, to the next, to the next, up to 7 brothers. And then the 7th brother dies. What happens then? Jesus answered him, and said unto them, Ye do err, not knowing the Scriptures, nor the power of God. For in the resurrection they shall neither marry, nor are given in marriage, but are as the angels of God in heaven. That wife was not married except on earth. And after that last brother died, she went on her own until she passed away. That brother goes on to be an angel, just as the wife. Neither that husband or wife would be together in heaven, but be angels. But this went on and on and on. Master, which is the greatest commandment in the law? And Jesus said unto him, Thou shalt love the Lord thy God with all thy heart, and with all thy soul, and with all thy mind. This is the first and great commandment. And the second is like unto it. Thou shalt love thy neighbor as thyself. On these 2 commandments hang all the law and the prophets. Jesus was not tempted. They tried. They failed. Another time earlier in his ministry, they took him to the highest pinnacle of the temple. Satan did. And again, Satan could not tempt Jesus Christ. He failed. Jesus Christ is Son of the living God. Jesus Christ is our Savior and elder brother. Only him, only through him can we be saved. Folks, we need to get to know the Savior. We need to read our scriptures and get to know the Savior. That's the only way we're going to really come out of this life and move back into heaven with our Heavenly Father, is to get to know Jesus Christ. We came to this earth for a reason, to gain experiences. We told Heavenly Father before we left that we would come here to gain experience and find our way back to heaven through obedience to the commandments of God. That's our mission here. I urge each of you to read your scriptures, know who the Savior is, and abide by the commandments. The scriptures teach us the way to go. They teach us the covenant path that we need to stroll, that we need to be on. May we all do that and help each other and love each other. The first and great commandment. God bless you, brothers and sisters. I love you to pieces. Please, folks, if you will, please hit the thumbs up button before you leave. If you're not subscribed, please subscribe. Please check your subscriptions and make sure you're still subscribed. Before we came on the air, we had 1,199 subscriptions, just shy of 2,000 people being part of our EMA family here. Let's go to further than that. 2,000, 3, 4, 10, 20, 25,000 people like we had on the last channel. May God bless you. Yes, we want that many people here so they will hear our message, so they will know what's going on. That's what we do here, to give you information to prepare, to help you get through emergencies and disasters. God bless you. God be with you. And I mean that. May God bless you and be with you until we meet again. Have a good night, brothers and sisters. I love you to pieces. We will see you on the other side. Good night, everybody.
For associates,
folks, this is Ron Tyler with the Emergency Management Associates coming to you live from the crossroads of the West in Lake City, Utah. The time right now is 7:05 p.m.
very clear on the backside of the sun, and the liner 2.8 who's hitting the earth is located around 3.5 miles southeast of the earth now. The solar wind is also